Hello and welcome to my solving a quadratic equation video here. So here what we'd like to do is to discuss how we can solve a quadratic equation, and let's just recall that a quadratic equation is in the form ax squared plus bx plus c, and it's equal to 0. But if we have something and it's not it's not in this form, then we have to manipulate what we're given to see if we can put it in this form. And then the idea is that we want to solve the quadratic equation. So there are many methods to solve. We are going to talk about solving by factoring. Okay, this is going to be our way of solving the quadratic equation. Now when you get to a college algebra class, you're going to learn another method called the quadratic formula. And then you're going to also learn another method called completing the square. I'm not going to discuss these. I just want to introduce these to you. Okay, and then finally there's a fourth one. You're going to use a graphing calculator and actually graph the graph of the quadratic, and then use your calculator to come up with what we call the x-intercept. So in this case, now, whenever we take a trinomial and set it equal to 0, or if we're given something and we manipulate, so the idea of solving, even back with our linear stuff, was to bring everything to one side, which automatically implies that we set it equal to 0 and then isolate the variable all by itself. So let's take a look at x squared plus 5x minus 6, and now we're going to set that equal to 0. And now the instructions is just going to be solve this thing, okay? So since this is in our basic form that we've talked about previously, we just write down our two brackets here. And here we get an x and an x. So what are the factors of negative 6? Now that add up to give me a positive 5. So if I take a look at 1 and 5, or I'm sorry, 1 and 6, let's just observe that since this is a negative up here, that one of these two has to be a negative. So if I choose negative 1, then 6 minus 1 is 5. And notice that that works. So we're all done right off the bat. So here we get minus 1 and 6. All right, so now we're going to employ another rule that says that if a times b is equal to 0, then a is equal to 0 and or b is equal to 0. Whoops, b is equal to 0. Okay, hopefully that makes sense. If you have a product of two numbers, the only way that a product of two numbers is equal to 0 is if a is 0, b is 0, or they're both equal to 0 at the same time. All right, so this is what we're going to do now as well. So if you will, and if you don't like the a's and b's, again, this is just pattern matching again. You can just say if square times triangle equals 0, then square equals 0 and triangle equals 0. So we just set the two factors equal to 0. So in this case, here's square and here's triangle. So square equals to 0 means that x minus 1 equals to 0. So x equals 1. And this says that triangle equals 0. So x plus 6 equals 0. So x equals negative 6. And again, we plug these back in up here. So 1 minus 1 is 0. 1 plus 6 is 7. 0 times 7 is 0. So that checks. Negative 6 minus 1 is negative 7. Negative 6 plus 6 is 0. Negative 7 times 0 is 0. So that checks. Okay. So again, there's no reason why you should get any of these quadratic equations equal to 0, or I'm sorry, quadratic equations incorrect, because you can always verify your solutions just like we did back with the linear stuff. So here we get 2x squared minus 3x minus 5 equals 0. Okay, So here, if we take a look, our AC method says take 2 times -5, so I get -10. So can we come up with factors of -10? So I get 1 and 10. And notice that one of these has to be negative. So if the 1 is negative, then when I add these together, I get 9, and that's not -3. And if the 10 is negative, then 1 minus 10 is -9, and that doesn't work out either. So here we get 2 and 5. Let's just observe if the 2 is negative, then the -2 times 5 is the -10, and -2 plus 5 is 3, which is not what we get. But if the 5 is negative, then our product is -10, and if we add these together, we also get our -3. So this is the 2 that we're looking for. So we get 2x squared plus 2x minus 5x minus 5 equals 0. So we go back and review section 6.4. Yeah, 6.4. All right, so our next thing is to group. So 2x squared plus 2x minus, and don't forget to flip the signs. We have to flip the signs, so we get 5x plus 5, and that equals 0. So greatest common factor, 2x, so I get x plus 1, minus greatest common factor here is a 5. So I get x plus 1 equals 0. So x plus 1 is common in both. So pull out the x plus 1. So I'm left with 2x minus 5 equals 0. So we get x plus 1 equals 0. So x equals -1. And 2x minus 5 equals 0. So 2x equals 5. Oops. 2x equals 5, so x equals 5 halves. And again, you can go back and verify that both of these are the solution. I've already done that in my previous work. So let's take a look at 4y squared minus 25 equals 0. So again, I'm looking at the difference, and I got a binomial going on, and I got a squares going on. So again, let's just note that I get 2y squared minus 5 squared is 0. So I get 2y minus 5, 2y plus 5 equals 0. So I get 2y minus 5 equals 0, 2y equals 5, y equals 5 halves, and 2y minus plus 5 equals 0, 2y equals -5, y equals -5 halves. Seems like 5 halves is popping up quite a bit here. I did not plan this, I promise. I promise. All right, let's take a look at another example. I got this one plus another just to let you know where we're at time-wise. So we get 4x squared plus 20x plus 25 equals 0. I actually want to take a moment and do two different ways of solving this. So the first way I would like to solve this is to take a look at the techniques that we talked about in section 6.4. And let's just recall that section 6.4 was to use the AC method. So to use the AC method, we can take 4 times 25, and we observe that we get 100. So now we have to come up with the factors of 100 that add to 20. So again, following my procedure, again, if you already see it, that's great. But notice that we start off with 1 and 100, and I think that's pretty clear that that's not going to add up to 100. Take 2 times 50, and I think that's pretty obvious that that is not going to add up to 20 either. Okay, so then we come down to 4 times 25, and I'm thinking that does not add up to 20. Okay, and then we come up to 5 times 20, and that adds up to 25, so that's not going to work. So then we get 10 times 10 is our last set, and notice that this does work. So now we can come over here, and the AC method says that we write this as 4x squared plus 10x plus 10x plus 25 equals 0. And in case you're wondering, notice that the 4 and the 20, but 25, notice that 4 is not a factor of all three of those. So to make the number smaller, that is this 100, factoring out the 4 as a greatest common factor just won't work. So now we use our factor by grouping. So 4x squared plus 10x plus 10x okay. So our greatest common factor here looks like a 2x. So we're left with 2x plus 5. Greatest common factor here is 5. So 2x plus 5 is 0. So 2x plus 5, 2x plus 5. So notice that we ended up with the same thing, and technically we would write this as 2x plus 5 quantity squared, but since we're solving and we have the same factors, notice that we just get 2x plus 5 equals 0, and long story short, x equals negative 5 halves. Kind of looks familiar. So again, this is the AC method, and I believe in class I tried to introduce the AC method when we were in section 6.3. So let's just come back to the section 6.3 method, and let's just recall that 4x squared plus 20x plus 25 equals 0. So remember, in the 6.3 method, we asked if we can write this as a perfect square. So notice that this is 2x squared, and we came over here to this and we wrote that as 5 squared, and then we asked the question, does the middle term equal to 2 times 2x times 5? And notice that 2 times 2 is 4 times 5 is 20x. All right, and notice that since that is true, then we said, oh, then this is equal to 2x plus 5 squared, and that has to equal to 0. So notice we came up with the exact same thing, two different methods. So the bottom line is, if you're given something like this and we ask you to factor, notice you have two different ways of saying the same thing or doing the same thing. You say casa, I say house, and if you're from down south, they say hoose. All right, so now we get 2x plus 5 equals 0, and again, x equals negative 5 halves. We end up with the same answer. We end up with the same factorization. Okay, but the methodologies that we used are totally different. All right, so this is what I was trying to say in class during the 6.3. All I want you to do is factor. I don't care how you factor. Let's just factor. All right, last example, x squared equals 32 minus 4x. So one of the things that as I look at this equation, one of the things that I'm honing in is I have an x squared variable, and that should be ding, 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 ding to me, saying, oh, I need to start immediately thinking quadratics. All right, but notice that this is not set equal to 0. So this is in the case where I have to manipulate this to 0. So notice all we do is bring everything to one side. So add 4x to one side. So I get x squared plus 4x equals 32. And now subtract 32 from both sides. So x squared plus 4x minus 32 equals 0. Now we have it in our form, and now we have our straightforward factoring. And I'm kind of hoping at this point in time that we can see that this is x, and the factors of negative 32 that add up to 4 is plus 8 and minus 4. All right. So again, we just take x plus 8, set this equal to 0, so x equals negative 8, x minus 4 equals 0, so x equals 4, and I'm hoping that you can plug it back into here and see that this is a solution. All right, so we got this down to 15 minutes. My final comments put us to 16 minutes. So again, if you've got any muddy points on this, please be sure to bring them to my attention so that we can take care of them in our next class session. Outside of that, I hope this helps you out, and I will see you in our next class session.